Today we're going to talk about rational exponents. When you have a rational exponent, that means the exponent is in the form of a fraction. So here's the definition of a to the m over n, or a to the power over root. In other words, m represents what power that base is raised to, and n represents what root will be taken. So if m and n are positive integers, and a to the 1 over n is a real number, then here are some different forms that we can use, which all mean the same thing. A raised to the fraction m over n can be translated as taking the root of that base a and raising to the power of m. Or you can take that base of a, raise it to the power first, and then take the root. My preference is for this middle form because if you take the root of a number first, you are shrinking that number to make it small before you have to raise it to the power. In the last example, if you raise a number to a power, you're going to make a very large number that you would then have to find the root of. And sometimes that can be more difficult depending on how large the numbers actually are. So my preference is always going to be take the root of the base first and then raise to the power. Now let's practice this evaluation process. In example 1, we're given 4 to the half. That simply means that 4 is raised to the power of 1, and then we're going to take the root of 2. So 4 raised to the power of 1, then we'll take the square root, or power of 2. Now you don't have to write 2. It's already implied that there's a 2 for the index if it's square root. But if you can write it if you want to. So that means we're really looking for the square root of 4, which is 2. That's our final answer. So what hopefully you're going to get from this is knowing that 4 to the power of half is the same thing as finding the square root of 4. With example 2, we have 8 raised to the power of third. So 1 is the power and 3 is the root. So 8 is raised to the power of 1, and then we're going to take a root of 3. Well, 8 raised to the power of 1 is just 8. But to find a cube root, that means when we go ahead and make our factor ladder, we really want 3 identical factors instead of just 2, like we did with square root. So we'll start by dividing 8 by 2 to get 4. We'll divide 4 by 2 to get 2. We'll divide 2 by 2 to get 1. And notice how we have 3 identical factors that make 8. So we know that the cube root of 8 is exactly 2. So 8 raised to the power of 1/3 is the same thing as looking for the cube root of 8, and that is exactly 2. In example 3, we have 8 raised to the 2/3. So 2 is the power and 3 is the root. 8 is raised to the power of 2, and we're looking for the cube root. So there's one way to write it, or we could take the root first and then raise it to the power. Either way, we should end up with the same answer. So if I raise to the power first, that means I'm looking for the cube root of 64. If I do it this other way, cube root of 8, well, we just found that out, right? Remember, that was 2. So this says to take 2 and square it. See, that's much easier. That would make 4. Now let's see if the cube root of 64 is really 4. To work that, I'd have to start with 64 and then divide by primes. So I could divide by 2 to get 32, divide by 2 to get 16, divide by 2 to get 8, divide by 2 to get 4, divide by 2 to get 2, divide by 2 to get 1. So this time, instead of looking for pairs, remember we have cube root. We're looking for 3 of a kind. There's 3 of a kind. 2 times 2 times 2, that makes 8. Here's another set of 3. 2 times 2 times 2. That makes 8. So what this means is cube root 8 times another cube root of 8. Well, we know that the cube root of 8 is equal to 2. We found that out down here. So this cube root of 8 is also worth 2. How much is 2 times 2? 4. So maybe now you'll believe me when I say that squaring the base first makes for a much more difficult problem. I highly recommend we take the root first and then raise to the power. Let's look at example 4. 27 is raised to the negative 2/3. So notice how the negative was placed in the numerator? That's standard form. So this power is going to have a negative 2. The root is positive 3. All of our roots should be positive numbers. So the way I'm going to rewrite this, root was 3, so I know it's a cube root. 27 is the base. If the power is negative 2, remember I want to take the root first and then raise to the power. So let's not worry about negative 2 at the moment. Let's just concentrate on finding the cube root of 27. So that means I'm starting with 27 and dividing by prime numbers. 27 divided by 3 makes 9. 9 divided by 3 makes 3. 3 divided by 3 makes 1. Notice how I have a set of 3. 3 times 3 times 3 is 27. So the cube root of 27 must be 3 because we had 3 identical factors. So what we're really looking at is cube root 27 is worth 3. So 3 is the amount raised to the power negative 2. So here is your test. What do you remember about negative exponents? There's no way to evaluate this problem the way it's written until we change the exponent to a positive number. So thinking back to how to change an exponent to a positive, 3 raised to the negative 2 can be turned into a fraction by dividing it by 1. This is helpful because anytime you take a base with its exponent and shift it across the division bar, you will change the sign of the exponent. So now our fraction will have 3 raised to the positive 2 in the denominator, and we'll have 1 over 3 squared, and that equals 1/9. That's our final answer. So take the cube root before you try raising to the power. And our final answer then is positive 1/9. With example 5, we have a negative 4 raised to the power of 1/2. The first thing you need to ask yourself is what is being raised to the power? And that is only the base of 4, not negative 4. There's no parenthesis to include that negative. So this is negative 1 multiplied by 4 to the half. That means negative 1 is going to be multiplied by 4 to the power of 1 root of 2. Remember, that's square root of 4. So we really have negative 1 multiplied by 2. Final product, negative 2. In example 6, we have negative 8 raised to the 1/3. Again, that's a very similar looking problem to example 5. Only base of 8 is raised to the 1/3, not the negative. We do not have a parenthesis here. So we translate that negative as negative 1 multiplied by 8 to the 1/3. So that is equal to negative 1 multiplied by cube root of 8. So negative 1 is multiplied by 2. So we know the cube root of 8 is 2 from the previous problems we just worked. The final product then is negative 2. So it is possible to have some answers that are negative. and that's because the negative was written out in front of the base. For example, 7, notice we have parentheses now showing up. So the negative is assigned to the fraction 8 over 27. This fraction is raised to an exponent that has a power of 2 and a root of 3. So I know it's a cube root problem, and I know there's a fraction involved, and negative 8 over 27 is the fraction, and this will be raised to a power. Remember, that was the positive 2. So I want to work with the cube root first before I raise to the power. Since we have a fraction, you might be thinking about the quotient rule. We could break this apart as the cube root of negative 8 divided by the cube root of 27, and then we can raise to power of 2. So the cube root of negative 8 simply means there must be some base that is negative that can be multiplied by itself 3 times. What if we didn't have the negative written there? Don't we already know that the cube root of 8 is 2? Since there's a negative involved with this problem, it is attached to the base, we're going to assign negative 2 for the final answer. See if that works out. Is negative 2 times negative 2 times negative 2 equal to negative 8? So the first two factors give us 4 multiplied by negative 2. Sure enough, that works out. So all of those factors must be a negative 2. Our denominator is a positive number. So when we're working with 27, we have 3 times 3 times 3. So the cube root of 27 simplifies as 3. So it looks like we've dealt with finding the cube root. All we have to do now is raise this new fraction to the power of 2. That means the quantity of negative 2 is squared. So that means negative 2 times another negative 2. That makes positive 4. In our denominator, 3 is also raised to the power. So 3 times 3 would give us 9. Positive 4/9 is the final answer. In example 8, we have a fraction raised to a power. Notice that the numerator here is negative 1. So the power is going to be assigned the negative 1, and the root is positive 2. So our fraction of 9/16 is under the root of 2, or square root, and then we're going to raise to power negative 1. So first let's concentrate on finding the square root. So breaking this apart using our quotient rule, we're looking for square root of 9 divided by square root of 16. Then we'll raise that to the power of minus 1. So our square root of 9 is 3, square root of 16 is 4. So now we know that 3/4 is raised to the power of minus 1. Since our exponent is a negative number, we know that we'll have to invert that fraction, and that is now raised to positive 1. So our final answer is 4/3. When you see an exponent of negative 1, it means to invert your fraction to get to the final answer. Now for these last 4 examples, we're going to write each of the radical expressions using rational exponents. So we're still thinking of our base of a raised to some power divided by some root. Right now, the number 7, it doesn't look like any power is written, so that's really power of 1. And we know it's square root, so that root is 2. So if we take our base, we know that it's written to the power of 1 over root of 2. So another way to write the square root of 7 is 7 raised to the power of 1/2. So we're taking this full circle. No matter which form of the number we're given, If it's given in radical notation, we can change it to rational notation. If we start with rational notation, we should be able to convert it back to radical notation. Let's try number 10. First, I'm starting with my base of A. So I'll write A. The power that A is raised to is 3. So 3 belongs in the numerator. The root that's given is 5. So that will be the denominator. A to the 3/5 is the rational notation. It's always power over root. For example 11, we have 5 raised to power of 1. So our base this time is a number. That's okay. Power is 1. So we'll start it off with a numerator of 1. And our root is 3. So 3 belongs in the denominator. The cube root of 5 is the same thing as 5 raised to the 1/3. Finally, example 12. Now this one looks a little scary, but we'll just take one base at a time. The first base is x. We know that we're going to have that raised to power over root. So for x, the power is 6, and our root is 3. Then we have a different base. Y is our other base. Y is also going to be raised to power over root. The power here is 10. Again, the root is 3. So if you can simplify either one of these fractions, then that's what we must do. So for the base of x, I know that 6/3 is the same thing as 2. So we really have the equivalent of x squared. But 10/3 is not going to reduce, so we'll just leave y to the 10/3. Here's our final answer written with rational notation.